Welcome to our course Data Structure. I am Sanzia Sultana, your instructor for this course. So basically data structure is a very critical concept in computer science that allow us to organize, manage and store data efficiently. They are the building blocks for writing effective algorithms. So it is very important in computer science. Now we will learn about structure and classes in our first lecture. So let's get started. Alright, so we will learn about structure, structs or structures, which is basically a composite data type that groups variables of different data types under a single name. So it's commonly used in C and C++ and other languages. So like it holds data like an array. Each unit of data in a struct is called a data member or member. So because they are called elements in arrays, but in structure they are called data member. In a struct, each data member can have a different data type, and in arrays the data type of each element is the same. For example, like a struct in C might be used to represent a student with fields like name, age and grade, etc. Well, struct is really simple and lightweight. It's mainly used for grouping related data. Typically memory is allocated contiguously for structure. Well, structure is also ideal for small data structure that don't require complex behavior. Here we defined we had like a structure card type where we have string, maker, integer, year and float price. Then we have the main function, integer main, where we have the where we are using this struct which is card type. So we are just adding this to these variables we defined on the struct. So here we are assigning Mercedes, the maker of this my car, then the year 2005 and then price, this one, and then we are just printing your car is your car dot maker. So this is the syntax of writing C++ language program. I will also include you will find the code of a big example we will see in this lecture under the folder in module. So here okay, like we saw in this example, an object of a struct can be assigned to another object of the same struct type. Like here we are so this my car equal to your car. This means this assign each data member in your car to the corresponding data member of my car. It also assigns an array data members, any array data members. Previous one, data is passed from main program to object and from object back to the main program. So you'll see, let's say we have a main program here and three object A, B and C. So here data is passed to object A, let's say, then it passed the data from object A to main program again. Then it passed back again. So just for your visual to have a clearer vision, I have these diagrams. Okay, Okay, so how the main program uses a class object. So one of the key principles in object-oriented programming is encapsulation. The main program, which is the overall structure controlling the flow of the software, does not directly access the data within a class object. This is because the data is encapsulated or hidden inside the object, safeguarding it from unintended modifications. Then secondly, for function-based interaction, instead of accessing the data directly, the main program interacts with the object through its public functions. So these functions, often called methods, act as the interface between the object's internal data and the external environment. Third, communication through parameters. When the main program needs to communicate with an object, it does so by passing data as parameters into the object's functions. This method ensures that any data processing or manipulation happens within the confines of the object's methods, adhering to the principle of encapsulation. Lastly, data flow via return types. So after processing, if the object needs to send data back to the main program, it does so through the function's return type. This method maintains the integrity of the object's internal state while allowing the main program to utilize the results of the object's operations. So this is how the main program uses a class object in 4 ways. So we will now see this. We'll now see this using a diagram or picture so that it will be clear for you. So let's say we have a main program and object. So in object, you'll see we have public functions and private data. So let's say, first of all, the main program calls a function in the object. If you see the picture, the main program calls a function in the object. Then the function accesses the data inside the object. Then the function returns a value back to the main program. Again, main program calls a different function, let's say, the data. First function is calling another function here, and then the second function is accessing the data. Then it is going back to the first function. It returns back to the first function. Then the first function accesses data again. Public class. Here if you see, the fourth one is get balance and the fifth one is get last check. We declared this balance function, balance variable, which is float data type, inside private. You see, we have 3 data here, 3 variables. First is balance, last check, last deposit. All of them are float data type, and these are all private, and these are all public functions. Inside these 2 functions, okay, here we are just calling this menu so that this will come first when we will run the code. So basically we are defining it here. So in the menu we have integer choice, and then it will say write a check, number 2 make a deposit, 3 get the balance, 4 quite, enter a number between 1 or 4. So you will just enter the number then, and it will then make the decision if whatever you enter. Alright, keep in mind the data members of a class cannot be accessed by main program. The object always retains the current values of its data members even when object code is no longer executing. Each function of a class can use the data members of the class as though they have been declared within the function. So okay, so maintenance refers to any work done on a program after it is put into operation. because we know the world constantly changes, programs have to be maintained, means modified to keep up with the changes. So when programs are maintained, the data members sometimes have to change. Private data members make it easier to maintain a program. So basically it involves any work done on a program after it has been deployed to keep it functional and relevant. As I said, as the world changes, programs must be updated to adapt new requirements and technologies. And during maintenance, data members might need modification to reflect these changes. Encapsulating data members as private makes it easier to maintain and modify the program, as I said, which reduce the risk of unintended side effects. So basically maintaining a program, so it is very important for a program to be maintained, and how private data members contribute to easier and safer updates. If it's accessed by 100 places in a program, let's say, then we have to change 100 lines of code in the main program. Here the main program calls foo from 100 places, you see. So on the left side we have a class where we have a program, a function foo, but from the main program on my right hand side, the main program calls foo from 100 places, let's say, suppose. So the data member should be private. So then foo accesses the private data members here on the left, like integer a, b, or c, let's say. If the data needs to change, the body of foo will need to be rewritten. However, the function call of foo and return type will stay the same. No changes need to be made in the main program. So that's why data members should be private. Program maintenance is easier this way, especially if there is more than one program using the same class. So your class may be accessed by hundreds or even thousands of clients or main programmers. So design need to be useful and flexible for them. So write your class for clients, not for the computer users. Focus on providing functionality in your class. Avoid including user interface code such as messages or prompts. Do not put code in your class which gives messages to user or asks user for information. Let clients handle this the way they want. So which allow the clients, like the main programmers, to decide how to handle user interaction, keeping your class clean and focused on its core task. So we can say that the importance of writing classes that are flexible and focused, leaving user interaction to the client programmers, is very important. So debugging a program with classes. First technique, make the classes and the main program and test everything all at once. Inefficient, which takes a long time to track down each bug. Second technique is test each class as it is made by writing a main program just to test it, called a test driver or a driver. So we'll see an example here. Here we have 4 classes, class 1, 2, 3, 4. We have bugs in the classes. The blue dots, the blue box, blue side is the bugs, let's say. And we have a main program. Let's assume it takes 2 hours on average to fix each problem. So runtime errors is 20. So we'll see in 2 minutes we have runtime error 19. That means it took 2 minutes to remove one bug. So in 20 bugs we have 90 bugs left. Then 18, we have 4 minutes uh, 4 minutes, and then 6 minute 17 runtime errors. Then if you can also see on the picture that the bugs, the blue color is fading slowly. Then 10 minutes 12, like, so we'll see class 3 bug is gone. First one, which is bug free, is class 3. Then on 20 minutes we have 10 bugs gone. Then slowly left, one bug left. Yeah. Okay, so here we have all the time. Here you'll see it's removing the errors. It took 40 hours, but using the second technique it took 14 hours only. So second technique is more convenient than the first one. Okay, so function definitions in the class specification. The following slides show that function definitions can be placed into the class specification. In general, we should avoid doing this because it is a hindrance to program maintenance. It is shown here because you will see code written this way during your career. So here, if you see the function definition in the class specification code, this is the code we were talking about. So see here the code. We will go through the code that I already uploaded, and if you have any question, then let me know. You can run it on code blocks, or you can use any online compiler, or you can use any other like Visual Studio or any other platform to run your code. Keywords in class, but it is up to you if you want to use public and private keywords in structure or not. So by convention, we use structure when we want all data members to be public. As I said earlier, it is typically defined and used within the client's program, not a separate file, and it is typically used for records of information. And classes, when we use classes when we want all data members to be private for maintenance purposes. So that's all for today's lecture. You can go through the lecture and you can go through the code. If you have any question or concern, always feel free to email me anytime. I will get back to you. And if you need any help, or if there is any point you don't understand anything, just let me know. I have my office hour on Friday, or by appointment, or we can schedule any Zoom meeting if you need. So go through because data structure course is a bit difficult, so you have to understand from the beginning. If you don't understand from the beginning, because on our future lectures it will be more hard. So I would suggest you to start reading, start studying from first day. That will be easy for you. So you have the syllabus in your module, so go through the syllabus, and if you have any question, just let me know. Thank you.